We know that common base is the easiest option, but sometimes it doesn't work. If we can't get a common base, what is our strategy? So remember, this is on your notes packet, those extra examples. We did B and D yesterday, so we're going to look at A, C, and E. So we add a log on each side. And then properties of logs, what happens? Well, but first,
The 2 exponents one goes before it.
yeah, bring down your exponents so that we can get all of our x's together. So I have two things multiplied with my log. That means we need to distribute it. When you are multiplying by the 2x, that's just your coefficient. It's just in front. So we have 2x log 3 minus log 3. Equals x log 0.4. We are trying to get our x's together. Since we have x in two spots, what we did is we moved those terms to the same side. X log 0.4 minus 2x log 3. So everything with an x is on one side. How does that help me? They aren't like terms, so I can't actually subtract them. What can we do? We want to be able to divide, so first we factor out our x. So now it's x times something, so to get x by itself, you divide. So that is my exact answer. Try putting it in your calculator to get the decimal approximation. You get 0.3529. Since the denominator has two terms, you have to put parentheses in the whole thing.
That might be.
The other option to kind of help prevent that is to use this in a, you can do it as a fraction and leave it in, you don't have to worry about
Would you prefer?
this.
Oh,
And then you can see it as a fraction and make
No,
sure you get the
no,
correct
thank you.
thing.
I put negative. Like negatives. 1 2 front.
Oh, because you flipped your term. This log 0.4 minus 2 log 3. 2 log 3 minus.
I had it like right over there, and then I just subtracted that and pulled that over there.
If you do this, you subtract this over to move this, we add it to get this.
Gotcha. It'd be positive.
Other questions? Let's do another exponential problem. Remember with these, we want to get the exponent by itself before we add logs. my exponential piece is 3 to the 2x plus 1. I need that by itself. So how would I do that? 6 times 3 to the 2x plus 1 equals 12. You can't do 6 times 3 because order of operations says you have to do exponents before you multiply. So we divide it. At this point, we can't get a common base, so what do we do? Mhm. The reason we add the logs is because of the property the exponent can come down in front. So then, if I want to get x by itself, what could we do? Yep, that'll work. I want to get this x by itself so I can subtract over my log 3. Then, I'm trying to get my x by itself. It's multiplied with both the 2 and the log 3, so I can divide. So we get log 2 minus log 3 divided by 2 log 3. Some logs. So yesterday we did 2 different types of log problems. The first type was when some terms had logs and some didn't. So our strategy was to get those logs on one side and we need to combine them. If 2 logs are added, how do you condense that? We multiply the arguments. So x times x plus 15 would be x squared plus 15x. I kind of did 2 steps there, I guess I distributed. Just in case you didn't see what I did. Now, once you have a log on one side, our strategy is change it into exponential. If there's no base written, what do we assume? So that means 10 to the second equals x squared plus 15x. 10 to the second is 100, so I can subtract that over. It multiplies to negative 100 and adds to 15. So if we set those equal to 0, we get negative 20 and positive 5. Am I done? No, we have to check. On these log problems, the argument always has to be positive. So if I look, 5 is fine, but negative 20 will not work. So 5 is the only answer on this one.
If we were to plug in that 5, it'd have to equal 2 also, right? I mean, I know
Yeah.
it's like the only one that could work, but you
Yes.
could also have to plug
Yes,
in.
you could do it on your calculator and get it to work out. Yep. Other questions there? The second type of log problem is when every single term has a log. Then what did we do?
Can't you just take all those off and just put 5 plus 4x divided by 3 plus x equals 3?
Yes. So technically you should condense those first, but you put them together correctly, so it's fine. If two logs are subtracted, you have to divide them. And then if there's a log on each side, you can drop them. So now to solve this, we have to multiply by the denominator, so taking each side times 3 plus x. So these cancel. 5 plus 4x equals, if we multiply this out, 9 plus 3x. If we subtract over our 3x, subtract over the 5, we get x to equal 4. Check it, just make sure your arguments are positive. They both are, so that answer is okay. What questions do you guys have for me? So today, we really need to practice these logs. So there is a handout posted on Google Classroom. We have quite a bit of time. So if you had any issues with Math Excel, this is also time that you can ask questions over that.